Hey everyone, welcome back to the channel. Today, we're diving into something super cool. Face detection and verification using Python in Google Colab. We'll use images of famous football players like Ronaldo and Messi to make it fun, and I'll explain every single line of code as we go. By the end of this video, you'll know how to detect faces in images and verify if two faces belong to the same person, all with free tools and some powerful pre-trained models. So, let's get started. Before we write any code, let's set up our environment. First, we must install two key libraries, MTCNN for face detection and Keras FaceNet for face verification. I'm typing this now. !pip install MTCNN. It stands for Multitask Cascaded Convolutional Networks, a pre-trained model that detects faces in images. Next, I'm typing !pip install Keras FaceNet. This installs the FaceNet model, which we'll use to generate feature vectors. Run that, and we're good to go. Now, let's import our libraries. I'm typing from MTCNN import MTCNN. This brings in that face detection model we just installed. Then, from Keras.FaceNet import FaceNet. That's for face verification. Next, import CV2. This is OpenCV, a super handy library for image processing like reading or resizing images. Then, import NumPy as NPE. NumPy helps us handle image data as arrays. Import Torch. This speeds up processing with some behind-the-scenes magic. Import matplotlib.pylab as PLT. We'll use this to plot our results. From scipy.spatial.distance import cosine. This calculates similarity between face embeddings. And from skimage import IO. This loads images from paths or URLs. Finally, I'm adding import warnings and warnings.filterWarnings ignore to keep our output clean by ignoring irrelevant warnings, and pultstyle.use dark background. This gives our plots a cool, dark theme. All right, run this cell and we're ready. Let's load some images to work with. I'm defining paths to images of football players, Cristiano Ronaldo, Lionel Messi, Kylian Mbappe, Neymar, and Erling Haaland. For each, I have 2 images. I'm doing this for all 10 images. 5 players, 2 each. Now, I'm creating a list called Images List with all these paths. Then, I'll visualize them. Plot.figureFigSize equals open parenthesis 15,7 close parenthesis. This sets a big figure size for our plot. Then I'm using a for loop. This loop runs through our 10 images. Inside this type, this creates a 2-row, 5-column grid for our images. Pult.subtitle to add a title. Next type. This will read each image and Pult.imshow displays it. To hide the axes type, this line will show the image number and its dimensions. Run this, look at that, 10 images of football stars. To color our text output, create a class Color, and then use ANSI escape codes for color. Now, let's detect faces. I'm defining a function called face detection. It takes parameters like image, model, color, URL, and size. Inside, I print a bold message using a custom color class we defined earlier. Don't worry about that, it's just for formatting. If there's a URL, img equal io.imread URL loads it. If it's a local path, then img equal plt.im read image does the trick. I set model equal model, which is MTCNN, which is our face detection model. Then coordinates equal model dot detect faces, img finds faces and returns their locations. Now, I'm plotting plt.figure for a wide figure. First subplot, plt.im show img shows the original image. And I loop through coordinates to draw boxes. X, Y, width, height, coordinate box grabs the face location, and then rect equal plt dot rectangle. X, Y, width, height, fill, false, color, color, draws a box. I add it with ax.addPatch open parenthesis rect close parenthesis. The second subplot shows key points: eyes, nose, mouth. I loop again, grab each point like left eye equal coordinate key points left eye, and use plt.scatter to mark them with red dots, size set bys. And also I noticed here, I made a mistake in the color class. So change this capital M to small m. Now create a loop to run the above function for IMG in image list. Face detection is an image IMG. And see those boxes and dots? That's MTCNN finding faces. Let's try a URL too. I'm loading an image from the web, typing the URL here, and running face detection URL equal URL size equal 2. So here we are getting an error. Here change the variable name. Smaller dots this time. Perfect. Now the last step is face verification with FaceNet. First, create a helper function which is reading.emg, which takes parameter img path. It uses cv2.imread to load an image and then this line to convert it from BGR to RGB. OpenCV defaults to BGR, so this fixes the colors. Next, face detection. FaceNet image. Margin equals 0.2, which detects and crops faces. Model equal MTCNN finds the face. And the detection zero box gets its coordinates. Then define margin, which is 20%. Xmin ensures we don't go negative, and the same for Yinmin. Similarly, define for max. Then use Facebox to crop. And then resize to 160 by 160 for FaceNet. Alright, this embedding function is for turning a face into a number code we can compare. Super important for checking if two faces match. FiMage with face detection is our cropped face image. Next, the model equals FaceNet. This loads the FaceNet model. Then creates the code with model.embeddings. Finally, return it. Next, create a function named similarity measurement, which takes parameters embedding vector1, embedding vector2, threshold 0.7. This will compare embeddings. This cosine function will compute cosine distance. If smaller, then that means more similar. Scan distance. Chasen distance less than threshold checks. If it's below 0.7, true means same person. Finally, this is the main function we're working with. It takes two inputs, img1 and img2, which are paths to images you want to compare. The goal of this function is to load the two images, detect the faces in them, extract features, or embeddings, and then compare how similar the faces are. Next, we're detecting the faces in each image using a function called face detection FaceNet. If both faces are detected, we're going to display them side by side using matplotlib. Here's the code for that. After plotting the first face, we'll do the same for the second face. Now that we've got the faces, the next step is to turn those faces into numerical representations, called embeddings. This is where FaceNet comes into play. At this point, we've extracted the embeddings of both faces. Now, we compare how similar they are using a similarity measurement function. Now, create a function, showing that's going to help us compare faces in two images and display the result. Right at the beginning, we have a message that lets the user know the comparison process is starting. Next, we call the comparison faces function we discussed earlier. Now, we check whether the faces are the same or not, and print an appropriate message. If the result isn't true, meaning the faces aren't similar, we go into the else block. After the result, there's a separator line printed to keep things neat and organized. This part of the code sets up a loop that goes through each item in the image list. Inside the loop, the showing function is called for every image in the image list. However, notice that it's always comparing the first image in the list, image list 0, to each image in the list. So here we are getting an error. So let's correct it. We put the face in a list with brackets because FaceNet needs it that way, and 0 grabs the first code, and embedding vector keeps it. Now run these cells again. That's it, folks. We've made it work. Thanks so much for watching and sticking with me through this face detection and verification adventure. If you liked it, please hit that like button, subscribe to the channel, and tap the bell so you don't miss more fun tutorials like this. You're awesome. See you in the next one.